Now, with our virtual machines installed and the course environment set up, we'll typically want to configure a virtual network for our lab machines to operate in. The exact steps to do this kind of thing will ultimately depend on your hypervisor, but in the documentation for your hypervisor, you can usually find instructions for creating something like a custom NAT network. And once the virtual network is created, we can go ahead and attach each of our lab VMs, any of our Windows workstations, our Linux VM, our Splunk server, all of these VMs, attach them to that network. This will place them on the same subnet so that they can interact with each other while still remaining logically separated from our host or production network. We also want to make sure that our virtual machines can still access the internet through our host, so we can, of course, install packages or run tools and scripts and perform enrichment lookups as we need to. This isn't a dynamic malware analysis curriculum, and so we don't really need to worry about isolating and creating an impenetrable sandbox to detonate malware securely. In VirtualBox, this is pretty straightforward, and the type of network that we want to create here is called a NAT network. And so from the VirtualBox documentation, a NAT network is a type of internal network that allows outbound communications, and that's exactly what we're aiming for here. And so to create this, I'll just head over to VirtualBox, and from the left-hand menu here, I'm going to go down to the Network Management tab. And so again, over time, the UI here can move around, things can change. And so just find where the main network configuration settings are for your version of VirtualBox. And from here, we have these different tabs. And so we can see, for example, the host-only networks option basically allows virtual machines to communicate only with the host machine and other VMs on the same host-only network. And so these networks are isolated from the internet unless routing is configured manually. And so it's useful for fully contained labs or different scenarios where internet access isn't needed. But in this case, it'll just make our lives a bit harder. And so what we can do is go to the NAT network tab. And a NAT network lets VMs communicate with each other on a private subnet while sharing the host machine's internet connection. Again, exactly as we described earlier. And so this setup is going to be ideal for our lab scenarios because it provides that isolation while still allowing the VMs to reach the internet, again, for updates or downloading tools. And so I'll click on NAT networks here. And from here, I'll click on this create button to create the network. And when we do, we can see that it's named as the default NAT network here, but we can modify this new network by right-clicking and then clicking on Properties. And so from this Properties pane at the bottom, I'm just going to rename it to SOC 201, just so I can reference it later. For the IPv4 prefix, here's where we can choose the private subnet that all our VMs will share. Again, ensuring that they can communicate with each other while remaining logically separated from other networks. And so I'm just going to leave it on the default settings here of 10.0.2.0 with a /24 network, but it's generally a good idea to pick a subnet that doesn't overlap with your host network. And so, for example, if your host is on a Class C network, you might consider using a Class A or a Class B subnet for your lab and using different prefixes here. This kind of keeps it visually distinct and it can sort of just help prevent confusion when you're managing IPs across multiple VMs. We can also choose to enable DHCP or Dynamic Host Configuration Protocol, which we can see is on by default. And I'd recommend keeping it enabled unless you have a specific reason to assign static IPs. It just kind of simplifies the network configuration for us and makes sure that each VM receives a valid IP address automatically. And from here, that's basically all the configuration we need to do on the network itself. You could optionally enable IPv6 or set up specific port forwarding if you need to. But again, for simplicity, I'm just going to leave all these features off. And so once the network itself is created, it's just a matter of attaching each of our lab VMs, again, the Windows workstations, our Linux VM, and the Splunk server, to that NAT network to place all of those systems on the same subnet. And we can do that just by going over to the Machines tab here, over on the left, just to list out all of our VMs. And one thing to mention here, just make sure that all your VMs are completely shut down and powered off before doing this. It can sometimes cause weird issues to happen if you try to hot swap the network adapters for whatever reason. And for each one, we can just right-click on the VM and then click on Settings. And from this Settings window, just click on Network. And this is where we can enable and configure the network adapters for our VM. And so here, I'm going to select Adapter 1, since as we can see here, it's the only one that should be enabled, the only one enabled by default. and I'm going to attach the VM to the SOC 201 NAT network that we just created. Alright, and so now it's attached, and just make sure that the virtual cable is connected, and we should be good to go. Excellent, and so now we just repeat that for the remaining systems. And so same thing for the Ubuntu VM, I'm just going to go down to Network here, and attach that SOC 201 NAT network. Great. For the Splunk VM, now this is entirely optional, but if you want to be able to access your Splunk web UI from your host operating system, like your host browser that you use outside of VirtualBox, you can make this VM dual-homed. And so that means that the VM will have two network adapters. One, as we've seen here, connected to that SOC 201 NAT network so it can communicate with the other lab machines, and a second adapter connected to a host-only or a bridge network so it can communicate directly with our host system. And so adapter 1, as we can see here, will be set to the SOC 201 NAT network, and adapter 2 will also be enabled here, this time attached to the host-only adapter. And so this setup will allow us to interact with Splunk both from any of our other VMs in the network, but also from our host without affecting that isolated lab network. Excellent. And so with all that complete, our lab network is now set up and ready to go. If we wanted to test that the network is set up correctly, we could go ahead and start up all of our VMs now and check their assigned IP addresses. And so on my Windows system, I can just open up a PowerShell session or a command prompt window, and from here just run an ipconfig. And by doing this, I can see that my IP address is set to 10.0.2.12. Over on Ubuntu now, I can open up a terminal window and just either run the IPA command, as you can see here, or run an ifconfig, and we're pretty much going to get the same information. And we can see, in my case, yours is obviously going to be different, it's set to 10.0.2.15. Now back on my Windows system, I know that my Ubuntu VM's IP address is now 10.0.2.15. And so to test the connectivity here, I can go ahead and ping that system. Right? So I can just type ping 10.0.2.15. Again, remember your IPs are probably going to be different. And if we're seeing these ICMP echo replies, well, that means we're good to go, and the connection can be established between those two systems. Now, we won't be able to go the other way around, right? We can't ping our Windows system from our Linux host, because that's just the way that Windows blocks ICMP traffic by default. If you really wanted to, you can get into the firewall and sort of enable that, but if we've confirmed that we get connectivity one way, then we're good to go. As another test, here I notice that my Splunk VM's IP address is 10.0.2.13. And so I should now be able to access it from either one of my lab machines by navigating over to the Splunk web UI, which is going to be http:// and then the IP address of 10.0.2.13, and then on port 8000. And if we're seeing this Splunk dashboard, then that's a great sign. It obviously means that we can access it. Since I created a second host-only network adapter for my Splunk VM, I can also try accessing it from my host internet browser. Now, this is an important concept to understand here. If you opted to dual home your Splunk instance like this, you're going to have multiple network adapters listed if you run an IPA command or an ifconfig command. And so over on the Splunk VM, I can see that I have an additional adapter, along with this additional IP address, right? We can see this is a different IP. It starts with 192.168. This is my host network, right? This IP address is on my host production network. And so this is the only IP that I can use to access Splunk from my host. That's just how the routing works, right? If I try to hit that 10.0.2.13 IP address from my host machine, well, it won't be routable, right? You can see we're going to get an error here. But if I go to that routable address, and again, yours is going to be different here, but if I go to http://192.168.162.6, and then on port 8000, well, now we're going to hit that Splunk web UI because it can route through the host-only network adapter and reach the service. Great. Now, one last reminder here. Typically, when you restore a VM from a snapshot, it's going to revert back to whatever network settings were selected at the time. And so just keep that in mind. If you ever revert back to your original fresh install for any of these systems, you might have to go back in and reattach the network adapter to your NAT network or whatever the equivalent setting is in your hypervisor. Or alternatively, just go ahead and take another snapshot now with these network settings configured, and you should be good to go to revert to it whenever you need to. All right, and so there we go. We've successfully configured our VMs and set up our lab network, and we're ready to continue on with the course. Great work.